My name is Grant Larson, and this is my Rotobot TinkerCAD simulation. So here we have each corner's respective motors. We have a tire roller motor to control the indexing of the tire, to lift arm servos in order to lift and lower the tire roller arms. We have our three cameras. Two of these would be proxied by one of the forward-facing cameras, but the other being proxied by the lug nut camera would be proxied by the upper forward-facing camera. The third camera on the model is purely for navigational purposes. These would be AI vision essentially, but these are currently being proxied by photoresistors. Down here we have the tire clamp motor, which controls the clamping arm, the lug nut hub motor, which controls that 5 lug centerpiece on the model. Because of the amount of motors and sensors that was required for this circuit, unfortunately I was required to use 2 Arduino boards and force them to basically communicate in order to make this work. However, due to both the complexity of this code as well as 2 random glitches I seem to have had with TinkerCAD where my code was deleted twice, I was not able to fully finish debugging and building this code out to the level that I would have liked to have. However, I would like to give you a quick simulation of what I do have here. I will just start the simulation in the background for brevity's sake and explain what it is doing as it is doing its thing. Here on the first Arduino board's code, I begin by starting the servo function as well as including the wire library for the 2 boards to communicate. I initialize all the different pins, give them their names, as well as assign them outputs, attach the servos, and begin this communication from the front board to the rear board. Here is various functions in order to control each one of these motors forward and reverse directions according to their location on the chassis. This means that the left and right motors are polarized opposite due to them facing opposite directions. Down here, I briefly describe the movement principles of mechanism wheels, as well as a brief explanation of the variables that determined the motor pulse times for the required distances for both 1 degree as well as 1 foot. This is based off of an 8-inch wheel and the circumference of the circle of the actual model. One thing to note is mechanism wheels have a 1-to-1 forward and sideways motion ratios, which means the same amount of the same amount of rotations will result in 1 foot in either forward directions or in sideways or in a lateral direction, depending on how you rotate the motors. Down here, resulting of the previous description of mechanism function, we essentially have a series of combinations of motors moving forward and backwards in order to accomplish either a forward or backwards motion or side-to-side lateral motion, as well as a clockwise or counterclockwise rotation around the robot's central axis. Down here is the stop function. This is the function that we use in order to raise and lower the arms. Here's the lower arms. This is the tire clamp function. This actually works as a passive function. So basically this will send a command from the front board back to the from the main board back to the slave board in order to have it activate a series of code on its board, since this is the board that controls the tire clamp motor. The tire lug installation, I was in the process of writing and trying to debug this code as this is unfinished. Essentially, the goal here is that this main board would passively be listening to the rear board, and if the command bit was 1 value, then it would move forward an inch. If it was another value, it would reverse an inch, and then once it contacted the lugs and it received that signal from the rear board that it had contacted, it would stop the board, and then there's going to be another section here where it would then send a command saying, okay, I've contacted the lugs, and then this would start the function of removing the lug nuts. This is just the simple loop that I have running right now. If we add apologies. Oops. Anyways, my apologies, I just broke that. So this is the slave board's code. Here we initialize the wire H again. Just going to quickly scroll through this all. I'm running out of time. Here I'm in the process of still debugging. Once again, unfortunately, this is not really finished code, so I don't have much to show here. But this is the conclusion of my presentation. And yeah, thank you for your time. Bye-bye.